Good morning. Today we are going to start our third day of matrices and we're going to learn about determinants and inverses. And we're going to learn about these because in our next lesson we're going to talk about solving matrices, and we'll be using both determinants and inverse to solve linear equations, solve systems of equations with matrices. So today's kind of a bunch of definitions. Not the most exciting, but we'll work through it. So I'm going to write a matrix down here, and I'm going to write matrix A. And I'm going to say matrix A is 5, 3, negative 1, 4. So the first thing, a determinant. So to figure out a determinant in a matrix, let's say you have matrix A, B, C, D are your elements. The determinant is often written with these vertical lines, looks like absolute value lines, but in matrices land that's determinant, and it's A times D minus B times C. So if I was to say the determinant of A would be 5 times 4 minus 3 times negative 1. So we got 20 minus negative 3. So we have our determinant is 23. So, and the 2 by 2s are all we're going to have to do by hand. You might be, well, what about a 3 by 3 or 4 by 4? Or you will always use a calculator, but to find a determinant, it has to be like a square matrix, like a 2 by 2 or 3 by 3. So now let's say I said matrix B was 6, 3, 4, 2. So the determinant of 6, 3, 4, 2 would be 6 times 2 minus 3 times 4. So all you're doing is multiplying those diagonals and subtracting it. So the determinant of this one is 0. Now the next thing we're going to look at today is inverses. And again, this is going to be really helpful for our next lesson when we're solving these systems. So to find an inverse of a matrix, if I had matrix A, B, C, D, the inverse is 1 over the determinant of that matrix times, and then you switch the order of some of these. So you change these diagonals, so DA, and then you do the opposite sides of these. And we're going to talk about some notation here in a minute. So let's figure out an inverse here. Let's take the inverse. So let's say I want you to find the inverse, I don't know what letter, and I always am using, of matrix A, which this time matrix A is 2, negative 3, 4, and 4. So notation-wise, A to the negative 1, that means inverse. So we first have to figure out our determinant. So let's see. So 1 over 2 times 4 minus negative 3 times 4 times, and then if we are looking right back up here, so I'm taking a look at this part right now, we got to switch our diagonals. So this would be 4, 2. And then we switch the signs, so positive 3, negative 4. So our inverse equals, let's see, this is 1 over 8 plus 12, 20, times 4, 3, negative 4, 2. So multiply that fraction in, so it's just 4 over 20, 3 over 20, negative 4 over 20, and 2 over 20. And we have our inverse. So let's see if we'll take a look at one more. So let's say matrix B is 3, 5, negative 7, and 2. So we want to find our inverse. So 1 over the determinant. So we got 3 times 2 minus 5 times negative 7 times, we switch those, so 2, 3, negative 5, and positive 7. So swap one diagonal and then the opposite. So this is 1 over, what is this? 6 plus 35. So 1 over 41 times 2, negative 5, 7, and 3. So we distribute that. 2 over 41, negative 5 over 41, 7 over 41, and 3 over 41. And we have our answer there. Now, you might be asking, about 3 by 3s. We're going to look at that in a second. Just one last thing I want to show you. So if I would have said matrix C is 6, 3, 4, 2, and I said find the inverse, so we have 1 over the determinant. So we find that determinant there. So 3 times 4 minus 6 times 2. We swap them, so 2, 6, make these the opposite. So if we notice here, this is 1 over 0 times 2, negative 3, negative 4, and 6. We can't divide by 0, so that's no can do there. So we'd say there's no inverse. And also no determinant, or the determinant is 0, but there is no inverse. So our determinant, just to clarify, is that bottom number. So our determinant is 0, because that's the number that's right here, but there is no inverse. So for higher order ones, so 3 by 3s and 4 by 4s, you will be able to use a calculator for them because it gets a little bit more complex. And I linked a Desmos matrices calculator into, you can just search Desmos matrices calculator. It's in just what's called a beta version, so it's not on the calculator yet. But to do this, and we'll double check these, 2 by 2s you will have to do by hand. But just to show you a new matrix, and this is a way you can check it. So if you wanted a 2 by 2, I will put one of ours in there. So we had 3, 5, negative 7, and 2. You got to press enter, so that's up on this line. And then everything else you're going to use here. So your determinant of A, it told us it was 41. And if you wanted to find the inverse, we just hit A, our matrix name up here, which is A, inverse. Because you can kind of see there's our, there's A, there's our matrix, we hit inverse, and there's the inverse of it. So you can name these differently. So let's say let's say you were asked to find a 3 by 3. And these you'll never have to do by hand. 3, 2, negative 5, 6, 4, 9, 1, 8, 3. Make sure you hit enter. So if you wanted to find the determinant of B, there's our determinant. And then if you wanted to find the inverse, we just hit B and that inverse, and there's our inverse matrix. So on Delta Math, if you are asked for any 3 by 3, you'll be able to use a calculator.